Hello friends, welcome to the Electrical and Instrumentation Engineering YouTube channel. In this video, we will learn about the transformer fittings. Here I have mentioned you the 14 number of for transformer fittings. Just pause the video and go through the transformer fitting. After watching this video, you will be able to understand the basic concept about this fit. This is the first fitting we are going to discuss. It is called a rating and terminal marking plate, also called as a R&D plate. The full form of R&D is a rating and drawing plate. Every transformer consists of this non-corrosive metal plate. In this metal plate, we will have information regarding the rating, voltage show, weight, oil quantity, vector group, OLTC details, basic insulation levels. Apart from my information, some other information is containing in this transformer nameplate. Please go through this transformer nameplate. And as per the transformer nameplate, rating and terminal mark plate will be mentioned in almost all transformers. The second fitting of the transformer is off-circuit switch. Almost all transformers fitted with the off-circuit switch, the off-circuit tap changer to get the required voltage ratio. So every customer requires the voltage ratio for their circuit. So almost all transformers which they are using contains the off-circuit tap changer switch. It is hand operated by a switch handle mounted on the tank on either side of the tank. See, I have enclosed the image. It is hand operated. And please note, the transformer stand should be isolated from the active lines before operating the switch. As it is an off-circuit switch, the transformer main line, the supply of the transformer shall be disconnected before operating the off-circuit switch. Also, if operated during the transformer charge condition, there may be chances of contact damage due to arcing and also may damage the transformer winding. Which means when the supply is live, if you operate the off-circuit switch and there are chances of getting the contacts damage due to arcing, or maybe it may damage transformer winding also. Hence, off-circuit switch can be operated only in the isolated condition. In most of the transformers, links are provided inside the transformer to obtain the required voltage ratio. Links are required to be loosened and to be fixed in the new position as per marking instruction in R&D plate. Every R&D plate consists of a off-circuit switch marking plate. So in this plate, they have mentioned the numbers, position numbers. As per the position number, we have to lose the links of the off-circuit switch and fix it to the new position. So links can be accessible from the inspection cover. So transformers having an inspection cover, and from that inspection cover, links can be visible and it can be accessed. If we are using a conservator tank, that means oil tank, then oil level has to be lowered below the inspection cover before unbolting the inspection cover, because the inspection cover having a oil, so you have to lower the oil level less than the inspection cover, and then only inspection cover can be opened safely and you can access the links. The third fitting of the transformer is earthing terminals. Most of the transformer consists of a 2 number of earthing terminals which should be connected to the earthing. So let's understand the reason for the transformer earthing. So you just see, every transformer consists of either small transformer or a big transformer. The transformer consists of a lamination core assembly. The lamination core assembly is connected to the core lamination frame. The core lamination frame is connected to the tank. There is a live supply will go through from the core lamination frame. In this time, there may be chances or leakage of current through the core lamination frame to the body. To secure the person from touching the tank, so we must earth the transformer tank body. That's why the 2 number of earth terminals are provided to the every transformer. Now the fitting number 4 is lifting lugs. I have enclosed the image of lifting lugs and how the transformer is lifted through the lifting lugs using the crane. Just see the brief description. Depending upon the size and its capacity, every transformer consists of a 2 or 4 number of lifting lugs. Or it is mounted either on the side or top of the cover to lift the complete assembly with including the oil-filled transformer. Please note that all lifting lugs shall be used simultaneously while lifting the transformer. Now the fitting number 5 is known as valves. Every transformer having a valve. There are 2 valves present in every transformer. You can observe. One is a drain cum filter valve which is located at the bottom of the tank, and another one is a filter valve which is located at the top of the transformer tank. Valves are generally fitted with the plugs or plates to stop oil coming out. There are 2 types of valve, mainly divided into wheel valves and butterfly valves. The wheel valve is also called as a shut-off valve. It is positioned or located between the conservator tank of the transformer and the Buccholz relay. And that is relay is fitted up to the 2 MVA transformer only. And the next type of wall is butterfly wall. The butterfly wall location is in between the main tank and the detachable radiators. Now the next fitting is the bushing. Every transformer winding has connected to the external circuit through the terminal bushing. The position of the bushing are different. Some of the transformers having bushing is located at the top of the tank, and some of are inside the cover. So the bushing lower end of is protrudes or dipped inside the tank. The both end of the bushing consist of a suitable fastener because it is to connect the internal leads of the transformer at one end and the external conductor either cable or bus duct which is to be connected at the other. Now the fitting is cable box. Every transformer consists of a cable box. Here in my side, my transformer has a cable box which I have enclosed here. Two photos I have enclosed. One is HT side cable box, another is LT side cable box. These boxes are designed with a suitable air clearances inside for PVC and XLP insulated cables. Also consist of a glands with the supply. And the higher rating transformers such as 3.6 kVA transfer, 2 MVA transformers having a detachable gland plates. And earthing terminals are also provided inside these cable boxes because to connect the armor of the cables to earthing. And some transformers are provided with the disconnecting chambers. In this my transformer, the disconnecting chambers has been provided at the primary and secondary side. The advantage of disconnected chambers is to transformer can be taken into service or overhauling without disturbing the cable termination. You no need to take the cable termination out and you can do the servicing of the transformer. That is the advantages of having a disconnecting chamber at the primary and secondary. In this slide, we will learn about the bus duct or trunking of the transformer fitting. I have enclosed two images. You can observe how the bus duct has been connected to the transformer and to the switchgear. So what happened? Some customers will ask for the connection to load the transformer through bus duct, not for the cables. So generally the bus duct will not be supplied by the transformer manufacturer. However, manufacturer will provide the suitable arrangement for installing a bus duct at your site. And like arrangement is like giving a flanges or trunkings around the transformer bushing to receive a bus duct. In many transformers, you can see a box which I have enclosed in the image. This box is known as a marshalling box. The uses of this box we will discuss in this slide. The transformer is having a many protection devices which is directly mounted on a various location of the transformer. Suppose example I will say Buccholz relay and pressure relief valve and winding temperature indicator, oil temperature indicator and many other protection devices which is located at the some side of the transformer. And what happened? The cable from all such protective devices will be wired up to this terminal box. This terminal box is a weatherproof terminal box and it is called a marshalling box. It is also used for the housing of winding temperature indicator as well as oil temperature indicator. I have enclosed the image of my site. Here we can observe winding temperature indicator at the left side and the oil temperature indicator at the right side. This box consists of a glass which is shown in the image to observe the WTI and OTI readings, and it is made by a metal sheet. And the advantage of the marshalling box is it has a hinged door with a locking facility to prevent the unauthorized access. Only authorized person can access this door by having a locking facility. And see at the top side of the marshalling box, it has a rain shade and a detachable gland plate and the below of that marshalling box. Now the topic is Buccholz relay. Buccholz relay is a very protective relay and it is a very sensitive and it is operated by a gas and oil. The relay is connected to protective device to give a early audible alarm for gas collection and disconnect the transformer from the main supply in case of severe fault inside the transformer. The relay, we will understand when the relay will operate or function. The relay will operate or function during the following condition. If there is any gas is accumulated inside the relay, then the relay will be operated. If the surge of the oil is developed on account of sudden increase of pressure inside the transformer due to the severe or sudden fault, then the relay will operate. Or oil level in the relay is reduced below the minimum level. At that time, this relay will operate. This relay is fitted in between the conservator tank and the main tank. I have enclosed the image. You just look into the image. And this relay consists of 2 mercury switches. And each mercury switch contains one for alarm and another for trip indication. The relay is always mounted in such a direction that arrow direction should be towards conservator tank. Just see, I have enclosed the Buccholz relay, which is a very important relay in transformer protection. Now the next fitting is radiators. What is the purpose of using radiators in the transformer? Let's understand. The purpose of using radiators in the transformer is to limit or control the temperature of oil and winding by dissipating the heat that is generated due to the losses inside the transformer during the service. So there are two types of transformer exist. One is a power transformer, another is a distribution transformer. Power transformer size is large and that is having a detachable radiators. Distribution transformers are normally in the small size and hence the radiators are welded to its tank body. Let's understand that during the installation phase, radiators needs to be cleaned internally to remove scales and the coat of varnish is to be applied. External surface of radiator is to be cleaned off all rust and one coat of red oxide paint is to be applied, which is followed by the final painting. This direction is to be used only during the installation. If you want to more detail about the radiators, I have another video and enclosed in the description. Just look into the on-and type of transformer, which is detailedly explained for a oil natural, air natural type of transformer. You can watch the. Now let's understand Silica Gel Breather in two slides. Now we will operate on the slide number 1. Every transformer consists of a Silica Gel Breather. The volume of the oil level will change with the temperature. Now let's understand why the oil level will vary in all the transformers. Because change in temperature may be the ambient temperature or load in the transformer or both the reasons. So the temperature will change with the ambient temperature or load inside the transformer. So what happens? When increasing in the oil level causes the air in the conservator tank will be pushed out and the decreasing in the oil level causes the air to be drawing. Just look into the graphical image format I have enclosed here. Just see the graphics and hence the transformer breathes when air drawn in. There is a possibility that moisture and dust may enter inside the conservator due from atmosphere which is sucked in. This contamination, this moisture and dust will deteriorate the insulation properties of the oil if it is entered directly without Silica Gel Breather. Hence the Silica Gel Breather will be useful in arresting the moisture and dust from air which is drawing. By continuing into the topic of Silica Gel Breather, now understand the parts of the Silica Gel Breather. The Silica Gel Breather consisting of 3 parts. One is the casing, second is the silica gel crystals and third one is the oil which is at the lower end of the casing. The silica gel in the casing will absorb the moisture. The function of each one is the silica gel in the casing will absorb the moisture and the oil in the casing acts as a coarse filter and removes the dust from the outside when it is passing through the oil. And let's see the colors of the silica gel. The silica gel color is blue when the silica gel is dry and turns it pink when it is saturated with the moisture. When we can say that silica gel is healthy when it is turned blue or it is saturated when it is turned to pink. Now we will discuss about the fitting that is called as a magnetic oil gauge. This is the dial type gauge. I have enclosed the image. This is a dial type gauge and it is an indicative device provided in the large transformers with a conservator tank at relative high level height from the ground. In large transformer, conventional glass oil level indicators are difficult to observe because there is accumulation of dust or change in color. Hence, the dial type of oil level indication will be useful. Hence, magnetic oil gauge will be preferred in the large type of transformer. Advantage of using a magnetic oil gauge is also having a NO contact. The NO contact can be used for alarm or trip as per the customer requirement. And the magnetic oil gauge consisting of 2 compartments. One compartment which is the oil side compartment, another compartment is a pointer side compartment. Both compartments are sealed against the leakage of oil by metallic diaphragm. Now we will move into the another fitting that is called oil temperature indicator. In shortly we can call it as OTI. Now the oil temperature indicators are provided in almost all transformers except the very small rating transformers. In our transformer, which is a 2 MVA transformer, it is provided with the oil temperature indicator. The oil temperature indicator consisting of a burden tube with a pointer arrangement for a direct reading of oil temperature through the glass cover. I have enclosed the image. You can just see it is a burden 2 with a point arrangement, and the reading of the oil can be done directly can be visible through the glass cover. The temperature sensing bulb, which is connected to the oil tank, which communicates the burden 2 through the armor capillary. See in the below in the bottom side of the OTI, there is a armored capillary. The temperature sensing will communicate the temperature through the burden 2, and the OTI consists of 2 pointers associated, and the one pointer is connected to the audible alarm. Another point can be used for a trip contact, and OTI is generally housed and wired up to the terminal strip at the marshalling box, which we have discussed in the previous slides, and having a window on the door for the observation. Till now, we have discussed about the transformer fitting. Now, we will see the optional fittings which is available on the transformer as per the customer requirement. Following are the optional fittings which are known as a repeater OTI and WTI instrument and resistor temperature detector, thermosiphon filter, flexible separator, oil level transmitter, and on-load tap changer. If you want any further more information regarding the optional fitting, you can just comment on my comment box for a required fitting instruction. So I will try to give you another video. And if you have any queries on the transformer fittings I have described till now, you can give a comment on the comment box. I will try my level best to explain you. Thank you for watching the full video. Please like, share and subscribe. If you like the video, it will boost me or encourage me to make another video. If you share the video, it will help some other to understand the concept of transformers. And if you subscribe, you will get the notification of my next videos. Kindly encourage me by liking and sharing, subscribing to my channel. Thank you.